Hey everyone, and welcome back to the channel. Today, we're diving into a story that sounds like it's straight out of a Hollywood movie. It's a tale about curiosity, talent, and how a 14-year-old kid managed to find a critical flaw in a system belonging to none other than NASA. This isn't just about a bug, it's about how a fresh pair of eyes can spot something that even the greatest minds might overlook. So, grab your popcorn, because this story is a wild ride. Our story begins not in a high-tech lab at the Jet Propulsion Laboratory, but in the bedroom of a teenager named Miles Solomon. Like many kids his age, Miles was fascinated by space. He loved looking up at the stars, dreaming of distant galaxies and alien worlds. But unlike most kids, Miles had another passion: coding. He spent hours upon hours teaching himself programming languages, building small projects, and exploring the digital universe from his computer screen. For him, lines of code were like building blocks, a way to create and understand the world in a new language. The stage for this incredible event was a program called Tempix, short for Timepix. This was a project run by the Institute for Research in Schools, or IRIS. The goal of the IRIS project was amazing: to bring real cutting-edge science into the classroom. They partnered with organizations like CERN and NASA to give students access to actual data from major scientific instruments. One of these instruments was the Timepix Detector, a special kind of radiation sensor installed on the International Space Station, or ISS. So what does this detector do? Well, the ISS is constantly being bombarded by cosmic radiation. The Timepix detector's job is to measure this radiation, logging where it hits, when it hits, and how much energy it carries. This data is crucial for understanding the space environment and keeping astronauts safe on long-duration missions. The IRIS project made this raw data available to schools across the UK. Students could download these datasets and analyze them. Just like real scientists, it was a brilliant way to get young people excited about physics and data science. Miles's school, Tapton School in Sheffield, was part of this program. When his physics teacher introduced the Tempix project, Miles was immediately hooked. This was the perfect intersection of his two greatest interests, space and coding. He wasn't just reading about space in a textbook, he was getting to work with real, live data beamed down from the ISS. He and his classmates were tasked with sifting through massive spreadsheets of data from the Timepix detectors. Most students might find this a bit tedious, looking at endless rows and columns of numbers. But for Miles, it was a treasure hunt. He started by looking for patterns, just as he was taught. The data files were supposed to log radiation hits, but as he scrolled through the data, he noticed something strange. Every now and then he'd find a reading that made no sense. Instead of a positive number representing a radiation strike, he found a negative one. Specifically, he saw the value -1 appearing in the data logs. At first he thought it must be a fluke, a simple error in the file he downloaded. He checked other files, and there it was again and again. It was a recurring anomaly. This is where most people might have just ignored it, thinking it was a meaningless glitch. But Miles's curiosity was piqued: a negative energy reading for a radiation particle. That's physically impossible. It's like saying something has negative mass or negative height. It just doesn't happen in our universe. He knew this couldn't be a real physical event. So, if it wasn't real radiation, what was it? He brought his finding to his physics teacher, James O'Neill. Together, they looked through the data, and sure enough, the negative ones were scattered throughout the logs. They realized this wasn't just a one-off error, it was a systematic problem. Miles decided to dig deeper. He organized the data and discovered a pattern. The -1 error didn't appear randomly. It only showed up when no radiation was hitting the detector. It was a null value, a placeholder that the system was inserting when there was no actual event to record. But why was this a problem? Well, imagine you're trying to calculate the average radiation exposure over a period of time. If you have a bunch of these -1s in your dataset, they're going to completely skew your calculations. Your average would be artificially lowered, giving a false, and potentially dangerous, impression of the radiation levels on the ISS. Think about it like this: if you're tracking your daily steps, and on a day you didn't wear your tracker, it recorded -1,000 steps instead of 0, your weekly total would be way off. You'd think you were walking far less than you actually were. For astronauts, underestimating radiation exposure is a serious health risk. It can lead to long-term health problems. So accurate measurement is absolutely vital. Miles realized that this seemingly small bug could have major consequences. Armed with this discovery, Miles and his teacher decided to contact the experts. They wrote a polite but detailed email to NASA. Now you can imagine what it's like for NASA to receive an email from a 14-year-old student claiming to have found a bug in their multi-million-dollar space station equipment. They probably get a lot of strange emails. But Miles laid out his evidence clearly. He explained the anomaly he found, the impossible negative energy readings, and the pattern he had identified. He wasn't just saying something's wrong. He was providing data-driven proof. The email landed in the inbox of a NASA analyst. At first they were skeptical. The systems on the ISS are tested and retested countless times by some of the best engineers in the world. The idea that a teenager had found something they missed seemed unlikely, but the analysts took a look at the data Miles provided. They ran their own checks. And to their astonishment, they confirmed it. Miles was right. The -1 error was real. What Miles had discovered was a subtle error in the software that converted the raw data from the Timepix Detector into a readable format. The algorithm was programmed to insert a -1 whenever there was a data gap, but it didn't distinguish between a temporary sensor hiccup and a period of zero radiation. Over time, these -1s were accumulating in the logs, corrupting the long-term datasets. NASA's team was incredibly impressed. They immediately got to work on a patch. They wrote new code to fix the algorithm, ensuring that from now on, a zero radiation event would be recorded as 0, not -1. They acknowledged that while they did have their own data correction processes, Miles had found the root cause of the problem, a fundamental flaw in the conversion code that they had missed. He didn't just point out a bad data point. He diagnosed the illness in the system itself. The news of Miles's discovery started to spread, first through the academic community involved in the IRIS project, and then to the wider media. People were captivated by the story. It was the ultimate David and Goliath tale, a young student with a laptop taking on the complexities of space agency, technology, and winning. He received praise from astronauts, including British astronaut Timepix, who was on the ISS when the data was being collected. Peake even tweeted about it, congratulating Miles on his find. For Miles, it was a surreal experience. He was invited to give talks and attend conferences. He got to meet and speak with professional scientists and engineers who were astounded by his work. But through it all, he remained incredibly humble. He often said he was just doing what he loved, solving puzzles. He saw the bug not as a mistake by NASA, but as an interesting problem that needed a solution. His motivation was pure curiosity, the desire to understand why the data was behaving in a way it shouldn't. This story is so powerful for a number of reasons. First, it's a testament to the power of citizen science and educational outreach programs like IRIS. By giving students access to real-world data, they're not just teaching them science, they're empowering them to become scientists. They're providing a platform for fresh perspectives and new discoveries. It shows that you don't need a PhD or a fancy lab coat to make a meaningful contribution. Sometimes all you need is a curious mind and the right tools. Second, it highlights the importance of not dismissing anomalies. In science and in life, it's easy to ignore things that don't fit our expectations. We call them outliers, glitches, or errors and move on. But often, it's in those very anomalies that the most interesting discoveries lie. Miles didn't dismiss the -1, he questioned it, he investigated it, and that persistence led him to an important breakthrough. It's a lesson for all of us. When something seems off, don't ignore it, dig deeper. Finally, Miles Solomon's story is an incredible source of inspiration. It shows that age is no barrier to making a difference. Here was a 14-year-old working on a school project, who ended up helping one of the most advanced scientific organizations on the planet. He reminds us that passion, dedication, and a willingness to learn can take you to incredible places, even, metaphorically speaking, to the International Space Station. His story has undoubtedly inspired countless other young people to pursue their interests in science, technology, engineering, and math. So, the next time you're working on a project and come across something that doesn't make sense, remember the story of Miles. Don't be afraid to ask why. Don't be afraid to challenge the status quo. Your curiosity could be the key that unlocks the next great discovery. Who knows, you might just find a bug in NASA's system. What do you guys think of this incredible story? Let me know down in the comments. It really goes to show that you're never too young to make a huge impact. Thanks for watching. And if you enjoyed this video, make sure to hit that like button and subscribe for more amazing stories from the world of science and tech. We'll see you in the next one.